Okay, so welcome back. We are almost finished with the UV training portion of this video series. And in the previous videos, we left off describing how to analyze samples on the instrument. So the difference between running a sample on the scanning feature and running the sample on the fixed feature. So we went through this process. We said that scanning was really only to find the wavelength that I should actually type into the instrument, and then fixed is for me to get data from it to actually do some data analysis, some calibration work, and finding some concentrations of different compounds. So that's what we're going to talk about now. We're going to talk about what to do with this data once I receive it. So here is the desktop on my computer, but whichever computer that you decide to use, you will probably have access to Microsoft Excel. And Microsoft Excel, of course, is part of the Microsoft Office, and that's the spreadsheet template that we want to use when we go into the actual data processing of the standards and the samples that's given to me, either for my lab practical or for the competition or for whatever reason is out there. So Microsoft Excel 2010 is the version that I'll be using. If you have a newer model than 2010, then it will look similar but not identical. And if you have an older version of 2010, of course it will look similar as well, but buttons might be placed in different areas than what you'll see on this computer screen. So the reason that I'll mention Excel 2010 is because during your lab practical and during the competition, this is what platform that you will be using in our laboratory facility. So 2010 or 2013, they're very similar. Okay, so if I click Microsoft Excel, this will pop up, and what I've done beforehand is I've just went into Excel and I have typed in the data that I have gotten from my laboratory analysis. When I've made my samples, when I put the samples onto the machine, when I got the absorbances, I've went ahead and put that into Excel. Now, how do I do it? It's very easy. This is the data that I've entered, but I'm just going to re-enter it over here so you can see how easy that process is going to be. So you literally just click on a cell, and I can type in ppm here. That's the concentration that I'm typically working with, parts per million. I know that in a traditional chemistry course, they often tell you to calculate things in molarity. Molarity is the way to go. Moles per liter, moles per liter. What is the molarity? That's great. But that's not really used in industry quite often, and it's not really used in our program either. And the reason is because when it concerns molarity, which is noted with a capital M, molarity is a concentration that's very common, but the problem is that what we do in the laboratory is so small, concentration wise, that when we look at molarities, sometimes these molarities are very, very tiny numbers. 0.0000 is not uncommon for us to see. And for us in a working laboratory or in industry that uses this equipment, molarity is just not going to cut it for us. These numbers are too tiny to worry with, and what we do is that we convert that concentration over to parts per million. Parts per million is the concentration that's typically the staple for everything that we do. When we talk about parts per million, this is also known as milligram per liter. So how many milligrams of stuff do I have dissolved up in 1 liter of solution? That is another unit that people typically feel comfortable with because they are working in milligrams and they've worked in liters before. And if you have those two numbers and divide them, you can calculate a ppm. So that's the unit that we decide to use. Those concentrations will be provided to you in your lab practical or in your competition event. It will actually have the calculation, at least for one of them there. And then you'll have to do a series of dilutions maybe. And you'll have to calculate your own concentration using the dilution formula, but it will at least give you a place to start. So part per million. So part per million for this analysis that I did was a 0, a 0.25, a 0.50, a 0.75, and a 1.00. I'm just keeping all of them with the same number of decimals here. Okay, so if I wanted to change the decimals that show up on the printout, I can do that if I want to by coming up here in the Home tab, and you'll see this button that says increase the decimal or decrease the decimal. And if I click those, that will of course increase the decimal number of the box that I'm on or decrease the decimal number from the box that I'm on. Excel has a default setting where it chops off all the ending zeros. It doesn't want to display them unless you force them to. All right, so the absorbance here, I want to show that one as well with 3 decimal places. It's probably what shows up on my report or my instrument, so I want to represent that in the spreadsheet for significant figure purposes, right? Okay, so once I scanned maybe my highest standard, I found the wavelength, and that wavelength I believe in the previous videos were like 571 or 573, somewhere in there. So I scanned the highest standard, I found my wavelength, and then I switched the machine over from scan to fixed. And I went into the software, I ran every single what we would call standard up here at the top, which are samples that I have made, and then I've ran every single sample that was given to me or sample that I've made as well. So I'm going to call those A, B, and C. I just type those in and hit enter. The absorbance values for my standards are on the report, so I just copy that information over into the spreadsheet. So 0, 0.117, 0.273, 0.4346, and 0.419. Again, the only thing that I have to do is click an empty box, we call them a cell, and you type in the number 0.491 and you hit enter, and that enters the number into the cell for you. Okay, so these are the standards, which means I've made them. I know the concentrations of what they're supposed to be, and the machine gives me a signal for those. And these are the samples, which means I don't really know what's in these samples here. It's my job to figure that out. So I'm going to have to use my standards in order to help me determine what my sample concentration will be. And the reason that we got to do this is because, look, here we have a sample. We've called it sample B. And that gives me an absorbance of 0.130. Well, what does that even mean? Right? This gives me an absorbance, but it doesn't give me a concentration. It doesn't tell me how much there's actually in there. So what I have to do is that I have to use this absorbance in some form or some fashion to determine what this concentration is. So up here at the very top, I can kind of eyeball that if I want. If I've made a series of standards with known concentrations, and I get their absorbances that correspond to those concentrations, then I can take this absorbance, 0.130, and kind of say, you know, it probably happens right in between these two numbers. So that sample concentration is between 0.25 and 0.50. It's somewhere in there, right? And then I can do the same thing with maybe sample C, 0.173. 0.173, if I look at this absorbance table that I've made, well, it's probably going to fit somewhere right in there between 0.25 and 0.50. I just don't really know. I can maybe take a guess, but there's an actual mathematical process in order to do this with. So that's going to be your very first step with your lab practical or the event competition. You're going to have to come in and you will make probably a series of standards. When you make these standards, you will run them on the fixed, and I'm going to type that in real big. We're going to run them on the fixed. You've got to scan it first to figure out what wavelength, and then you run them on the fixed to determine what the absorbances are. So I'm going to write that over here to the side. I'm going to scan it first, and this gives me the wavelength that I need. I then go to the fixed. I make the instrument go to, that's what we call that, go to the wavelength that we just determined, and then I analyze my standards and I analyze my samples at that one specific number. We talked about that in the previous video, right? Okay, so these are the numbers that have showed up on that report. These are the numbers that showed up on that analysis run that we did in the last video. And now the next step is to figure out how can we mathematically prove what these concentrations are. So this is the setup of the Excel. And in the next video, we'll go through and we'll talk about how to process this data, and we'll bring in a little bit of math work and make some mathematicians happy for a change.